Okay, welcome back, everybody. Looks like this is going to be our last lesson or recorded video for chemistry for my class, and we're just going to end it off with titration. What is titration, and how is this related to what we learned from last week, which is on acid-base properties and reactions? Okay. So let's start with this. Let's say you have a flask. Imagine, you're in your laboratory setting, and I gave you, let's say, 120 milliliters of this unknown acid. And for this concentration, we're going to use molar or molarity. And let's say this unknown acid is going to be hydrochloric acid, which is HCl. Okay. So your job is to figure out this unknown concentration for this strong acid. And what we're going to do is we're going to use something called titration, which is a process for us to determine, let me write this down, we can use this to determine the concentration of a substance. For this substance, it's going to be hydrochloric acid. Okay, and there's several equipments that we can use to carry out titration, and we're going to be using something called a burette. Okay, so a burette is a long glass tube, and what it does is you're supposed to fill this burette with a solvent and use it to slowly add that particular solvent to your unknown. Okay, so how do we figure out the unknown concentration for this hydrochloric acid? What we need to do now is we need to add a strong base or a base to this acid. Okay, and for this particular base, we're going to be using a 2.0 molar of sodium hydroxide. Okay, so that's your strong base. And for the next part, what we're going to do is the reason why we're using a strong base is, again, you want to neutralize that hydrochloric acid. So when you neutralize something, you want to bring the pH up to 7. Okay, remember, when you start off with hydrochloric acid, the pH is going to be lower than 7, but when you start adding a base to it, you're going to increase that pH. Okay, and I'll tell you why you need to bring the pH up to 7 in a bit. Okay, so let's say before you start titrating it or slowly adding the sodium hydroxide, you got to make sure you add an indicator, a particular indicator, to this unknown first. Okay, so indicator, I'll put here. Okay, an indicator we typically use is called PHP, which is phenolphthalein. So I'm going to abbreviate that. Okay, why do we have to add the indicator to it? Well, how do we know if the pH turns 7? You're going to see the color change from clear to a light pink, which means you have neutralizers. So it's very important that you have to add the indicator, because if you don't, you're not going to see that color change, and you won't know if you neutralize that solution. Okay. So the next thing is this. Let's say I have this graph here. Okay, this is called my pH curve. Okay. Your y-axis is your pH, and the volume added would be for your NaOH that you're going to be adding to the hydrochloric acid. So let's say you start off with pH lower than 7, so around 1, 2 for this hydrochloric acid. Imagine you're plotting this. Once you're slowly adding the NaOH, notice the pH is going to go up because you're adding a base to that acid. Okay. So once you reach a 7, you're going to see the solution turn pink or light pink, which means, yes, you have neutralized. Okay. So at this point here, this is called your endpoint. Okay. It just means that when pH turns 7, the volume they add in, again, I'm just making this up. Let's say it's 15.7 mils of sodium hydroxide added to the hydrochloric acid when the pH turns to 7, which means you neutralize it, okay? I'll put this, neutralize it. Okay, so anyways, what do we do now, right? We know how much base we added until you neutralize the hydrochloric acid. It's 15.7 mils of sodium hydroxide. And we already know how many mils of the hydrochloric acid we had at the beginning, 120. And we have our known concentration for that strong base, NaOH, which is 2.0 molar. Okay, so we can use all this information to help us figure out that unknown concentration. So next, before I show you guys how to do that, let's go ahead and set up an equation first. Okay, so again, we have hydrochloric acid, balance equation, and we're adding sodium hydroxide to it, or excuse me, we're adding the sodium hydroxide to the hydrochloric acid. And what's going to happen is you're going to form two things. Again, you have an acid, and you have a base. So this is called the acid-base reaction. You're going to form two things. One of it is going to be water, and the other thing is going to be a particular salt, right? Salt means you have your cation and your anion, and if you guessed it, it's going to be NaCl. Okay. So you're going to have a particular salt, and you're going to have water, which is H2O. Okay. So this is typically what you're going to have when you have an acid-base reaction. Okay. And it's kind of like a pattern that you're going to see. So here it is, and voila. Okay. Remember, hydrochloric acid is strong acid. Sodium hydroxide is a strong base. Okay. So next, right? So here's my equation. So next, I'm going to use stoichiometry to, again, figure out the unknown concentration of hydrochloric acid. So the next thing I'm going to do is I'm going to start by using how much of the sodium hydroxide you put into that unknown. So we use what? 15.7 mils, okay, of sodium hydroxide. Next thing I want to do is I'm going to go ahead and convert this to liters. So 15.7 divided by 1,000. Okay, it's going to give me 0.0157 liters of sodium hydroxide. Okay, next times. For the next part, I'm going to figure out how many moles I have in 0.0157 liters of sodium hydroxide. So how do we figure out the number of moles? I'm going to go ahead and use the concentration molarity of sodium hydroxide. So this time around, I'm going to multiply to the concentration, which is 2.0. Again, this is given to you. Moles of sodium hydroxide. Again, 1 liter of sodium hydroxide. All right, so by definition, 2.0 molar of sodium hydroxide is the same as 2.0 moles per 1 liter of sodium hydroxide. So I'm going to cancel the liters here. So now I'm left with moles of sodium hydroxide added to that unknown acid, okay, the concentration. Okay, next, times. Okay, so this is the next part. I need to figure out, so at the end, I want to figure out the concentration, unknown concentration of your hydrochloric acid. I'm going to use the balance equation to set up my mole ratio. So notice from above, HCl plus NaOH yields NaCl plus H2O. Is this equation balanced? It is. 1 sodium on each side, 1 chlorine on each side. You have 2 hydrogens on each side and 1 oxygen. Okay, so for every 1 mole of sodium hydroxide that I put in, I need 1 mole of HCl is required there. Okay, there you go. So for the next part, I'm going to calculate the number of moles that the HCl consume, right? Again, for every 1 mole of NaOH that you use, 1 mole of HCl is going to be consumed in this reaction here. So I'm going to take 0.0157 times 2, and of course, times 1 over 1, the same thing. And you're going to get 0.031. I'm going to count for sig figs, and this is your number of moles of HCl being consumed. Okay. Now, this is your number of moles, but again, I need to figure out the concentration and molarity for HCl. So what's the next step? Well, simply ask yourself how many mils, what was the volume that you used at the beginning? Remember, you put in 120 mils of hydrochloric acid into that flask. So that is your volume. And what you want to do now is divide it by, instead of 120, you're going to make sure you convert it to liters. So now you're going to get 0.12 liters of HCl. Yeah. So go back, 0.031 divided by 0.12. It's going to give you a concentration of 0.26 molar. Okay. I'm going to count for sig figs too. So let's come back to the top again. Okay, remember, our objective was to figure out the unknown concentration of this hydrochloric acid. I gave you at the beginning 120 mils. You slowly added a base to it, and you're given the known concentration, which is 2.0 molar. You're adding a base to the hydrochloric acid because you want to neutralize it to bring the pH up to 7. Okay, add the indicator before you titrate it because you want to make sure the color changes. If it changes to light pink for that particular indicator, it means the pH has reached 7. Okay. When you reach the end point or the neutralization point, it tells you the number of moles of your base consumed is the same as your number of moles for the hydrochloric acid based on your reaction equation. Okay, so I'll answer at the end. What is the unknown concentration of HCl? It's going to be 0.26 molar. Okay, so there we go. This is something we use. It's called titration to figure out the unknown concentration of a substance. Okay, titration because you're slowly adding a titrant to the unknown.